Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you very much for joining this session on combining machine learning with Power BI. My name's Alex Whittles. All of my contact details are up on the screen. Do feel free to get in touch with any questions you have about content we cover in this session. A little bit about me before we start. I'm on the organising committee for SQL Bits, so a very big thank you for joining us this week. I've got a master's degree in business intelligence, which focus a lot on the machine learning side of things. And I'm principal consultant for Purple Frog, which is a BI and data analytics consultancy based in the UK with a global client base, covering all aspects of data warehousing, ETL, cubes, Power BI, machine learning, etc. And I'm also a data platform MVP and have been for 6 years now. At Purple Frog, we also have developed a bit of software called Power BI Sentinel, a software as a service that wraps up your Power BI world to provide disaster recovery, auditing and governance functionality to give you greater management of your Power BI tenants. Again, if you're interested in hearing more about that, then let me know. When I'm not doing all of that, I'm also a qualified pilot, and that's me on one of the most fun days of my life, getting to fly a Spitfire. Okay, on with the content of the session. What are we talking about today? We're going to be covering a pretty fast-paced set of demonstrations through different approaches for combining machine learning into Power BI. We'll be looking at some of the more easy options with built-in visuals, either out of the box or with custom visuals. And then we'll be looking at consuming Azure Cognitive Services, pre-built libraries of machine learning functionality that Microsoft exposed that we can hook into. And then we'll get into a bit more detail about how to create your own machine learning libraries using Dataflow, Automated ML, Azure ML Studio, and then even a bit of Python at the end, embedding that directly in Power BI. So it's going to be a relatively fast-paced session. Entirely demos. This is one of the last slides you'll see in the session till we get to the very end. Hopefully you can keep up. At least this session's being recorded, so you can watch it again later at a slower pace if you want to. Okay, on with the demos. Everything that we look at today is going to be using two primary data sets. The first one is a set of vehicle data. This is a set of cars with various attributes, features such as the number of cylinders, the size of the engine displacement, horsepower, weight, acceleration, year, etc. And we'll be using this to predict the miles per gallon, the MPG, or the efficiency of the vehicle. So we'll be predicting this MPG column, and we'll be using all of these numerical features to predict that. The second data set we'll be looking at is a fictional set of tweets, and we'll be using this for the more semantic analysis for text data. So we can see here we've just got the tweet text, the tweeter and the date. Okay, let's start out with some of the built-in visuals that we have within Power BI these days. We're going to be looking at the MPG data, the miles per gallon data initially. And there's a relatively new visual in Power BI, which is the key influencers visual that we see here. If we drop this onto the canvas, we can then decide which columns we want to include. So the first thing we want to do is we're looking at the miles per gallon, which is the output column, the thing we want to actually analyze. And then we can provide all the other columns that we want to include in this analysis. So we're going to add acceleration, country codes, cylinders, displacement, horsepower. We're not going to include model because we're not doing any text analysis. We are going to include weight and year. I'm just going to change some of these to stop them averaging to make them don't summarize. There we go. Now, straight away, as soon as we select these columns, Power BI is building a very, very quick machine learning model behind the scenes and running some statistical analysis over our data to understand and provide some context as to the influence that each of these source fields has, each of these features, as to how they impact the output miles per gallon. So So we want to know what makes MPG bad. So we're going to change what influences MPG to decrease. And it gives us a ranking. So the highest impact is the acceleration. We know when the acceleration is high, then the miles per gallon is going to get worse. We also know country code 1 is quite bad. Now, country code 1 being America, like their muscle cars, not quite as fuel efficient as Japanese or European cars. So that makes sense. Also, weight is the next biggest influencer, and followed by year, horsepower, engine size, and the number of cylinders is the least impactful. So this, although this doesn't give us a prediction, it gives us a very, very clear view of, if we're trying to decide how to build our next vehicle, which of the features generally are going to improve or decrease that MPG, and gives us some idea as to which of the features we should be concerned about most. If we click on in any of these features, we can see a breakdown of a categorization of them, in some case a scatter plot, so we can see here a very clear correlation like that. And then for year, etc., quite a positive correlation, so as the years go on, our MPG increases. So this is a very, very easy way of accessing simple understanding about data. Now, one of the key things here is that a user using this has no concept that it's using machine learning. And we're democratizing machine learning down to a simple Power BI visual. Behind the scenes on this, there's a lot of mathematical complexity going on, but it's detached from the user. The user doesn't have to care about it. It's very, very simple to access, very easy, and it's not scary, but very accessible to your business users. We can also use this to segment our data. So with the visual here has identified 4 key segments. And a segment is like a cluster. It's a group of vehicles that exhibit similar behavior, similar features, similar values. So we can look at segment 1, which is the worst MPG, and we can see that the general features that this category, this segment has: cylinders less than 5, horsepower greater than 139, and year less than 1974. So again, we can use this to cluster customers' behavior, etc. Okay, we also have a decomposition tree. Our decomposition tree uses very similar back-end functionality, where we can say we want to analyze the MPG, and we want to break this down by all sorts of different features. So let's bring on the acceleration, the country code, all of the fields that we did before. There we go. And so now this allows us to say, okay, all of our vehicles have a certain MPG. We want to expand this, and we can choose to break this MPG down by, let's say, country code. So we can now see a grouping of all country code 1, 3, then 2, etc. But instead of deciding which attributes to drill into, we can use high or low value, and this uses that feature influencer value to say, okay, let's look at the highest impacts. Let's drill down. In this case, it's cylinders that it's identified here. So it'll help us drill through our data in order to explore it without having to really know too much about the relative influence. The next visual we'll be looking at is the Q&A visual. And this is a way of providing a free text question into Power BI. And Power BI does some semantic analysis on that question to try and understand what it is we're asking for within the context of the data set. So let's ask this, show me the best car. Now this has a problem. There's 2 red lines here. It doesn't understand what best means, and it doesn't understand what car means. So we can click on this and we can give it some definitions and provide some synonyms for the data. So straight away, a car refers to, well, in our data set, we call it a model. So let's say a car refers to model. And now it understands what car means. It'll give us a list down here, and we can also see a preview in the window over here. So what is the best model? Well, the best model is high MPG, and it actually gives us a few suggestions here, so we can choose high MPG. And this is one of the challenges with the Q&A visual. This demo works half the time, it doesn't work half the time. It very much depends on what mood Power BI is in. Even though it gave high MPG as a suggestion, it's giving me a red box to say it doesn't understand this definition, and so we can't use that. Now this is a bit ridiculous because normally if high doesn't work, we can say low MPG, and that does work, and it now gives us the lowest MPG. So it understands high, low but not high, and you get this problem quite a lot with Q&A. So although it's there, it's a useful and expanding and improving system, it's a little bit unready for full release. It does say at the bottom that it is a preview feature, so use it a little bit with caution. As well as the built-in visuals, there's also a growing number of custom third-party visuals that offer machine learning functionality in Power BI, which we can access by getting more visuals from the visualizations pane. And in the advanced analytics section, we've got a whole load here that we can play with. I'm going to search here for clustering, and we're going to bring on the clustering using optics by Mac Software. That's enabled, and we can then drop that onto the canvas and then expand our MPG and bring on let's say the MPG on the Y. We just need to make sure these are set to don't summarize, and then let's have a combination of displacement and weight on the x-axis. Check they're both set to don't summarize. And then it'll have a look at that data and identify one or many clusters of groups of common data points. Now in this instance, it's found they all have a very similar pattern. They all form one cluster. This may define multiple groups and multiple clusters, which can be useful for identifying different groups that have different characteristics. But in this case, they're all in one cluster, apart from this one entity at the top up here. And we can see what that is by dragging the model onto the tooltip, and when that refreshes, we can see that there's one data point, which in this case is a Mazda GLC. Now, I know in this case that this is dirty data. It could genuinely be an outlier, but it's very important to run this kind of data profiling across your data before doing a lot of machine learning work on it. Because when you do have these kind of outliers, they can have a big impact on the quality of your prediction models. So running your data through clustering and outlier detection visuals like this can give you a very clear view on what data you need to remove from your training data sets, or potentially just be aware of it so that you can understand the impact if it does have an impact on your predictions. You can also use these kind of things, outlier detections, for just understanding your data before actually presenting normal analytical reports, to understand whether your data is actually clean or not, and does it conform to the standard pattern. So moving away from the visual side of things, how can we use ML to help us transform our data to get more meaning out of it? And to look at this, we're going to start looking at the Azure Cognitive Services, which are a pre-built library of machine learning functionality that Microsoft provide that we can hook into from many sources, including Power BI. To do this, we're going to go back into Power Query. And if we look at the top right, we see a set of AI insights. And we're going to be using the text analytics, one of these. And this is a set of text services that you can use to help you interpret, understand, and get meaning out of text. So how do we do this? Well, in order for this to work, we need to have Power BI Premium. As soon as you have Premium, then when you click the button, it'll search for your Premium capacities and give you a list of which one you want to use to do this. Here I'm going to use my embedded. If you don't have Power BI Premium, you can always use Power BI Embedded, spin up an Azure resource for that. As long as you have at least an A2 SKU, then you get access to the same machine learning functionality. In fact, all the same premium functionality you get in Power BI Premium. So we've chosen our capacity, and we've got a few choices here. We've got, we can detect the language, useful in a multilingual set of data you're trying to analyze. We can extract key phrases, and then we can score sentiment. We're going to be using the score sentiment option here. If we choose that, we can then say we want to pass through a column, and we're going to be using the tweet column. We can pass in a language if we want to, but it's optional. It'll detect the language if we don't. And as soon as we do this, it's going to, let's apply the changes. And that will now add an extra column to our data. So now we have in our tweets, let's have a look at our data set, we now have a score sentiment column. We just need to change that to a decimal number. Most responses that come out of machine learning algorithms return it as text, so always be sure to convert it to a number before doing any analysis on it. And this gives us a number between 0 and 1. 0 being a negative sentiment, 1 being a really positive sentiment, and 0.5 being it's on the fence, it's not quite sure. So we can use this to rank our tweets as worst and best. So to prioritize our workload. Now, this isn't just obviously the tweets. We actually use it within SQL bits to analyze the feedback that you all provide. It's a really important part of running bits, is understanding what you like, what you don't like. And with many thousands of you all attending a lot of sessions, there's a lot of feedback we have to work through. And as a relatively small committee, we need tools like this to help us extract the key phrases of the key concepts that are included in the feedback, and then obviously any free text, understanding the positivity, negativity, so we can focus our attention on the most important things first, and then obviously we work through everything, but it gives us a way of prioritizing. Okay. So all this is in Power BI Desktop. If we look at the Power BI portal, I'm not sure if any of you have played with data flows, but data flows are a Power Query table. There's no relationships of any data in there. It's purely just a Power Query that creates a table. And they're great for for managing data loads and standardizing your data across multiple Power BI data sets, etc. But there's also a huge amount of machine learning functionality that you can use from data flows as well. So that'll be the next thing that we jump into and take a look at. So if we jump into our Power BI portal, here I've got a SQL Bit 2020, obviously it's a premium capacity workspace, and I'm going to create a new data flow. I'm going to define a new entity, and within this we're going to, let me just get my code. We have the same Power Query functionality, or very similar Power Query functionality than we have with Power BI Desktop. I'm going to choose a blank query here and then paste my M code in there. Now this is loading the same MPG data set that we were using a minute ago. Just need to sign into the Azure SQL DB so I can pull the data in, and here we go. And so we have the MPG and all the other columns that we saw in here. Once we've got this, I'm just going to call that MPG, and we can save and close. So this Power Query now goes and gets that table of data, prepares it using, let's call this MPG. There we go. This pulls that data down from our source, in this case an Azure SQL DB, and it brings through a table here, MPG. Now we can consume that from within Power BI if we want to, but we can also click a button over here to add a machine learning model against this this particular entity. So we've got multiple columns in here. We're going to choose the MPG as the field we're going to predict. the entity that we're going to use, the table, and we're going to predict the MPG column. So this is essentially the table, the entity, and that's the column we're going to predict within that table. And data flows works on auto ML, auto machine learning. It looks at your data and tries to work out what the best model, machine learning prediction model can be for the data you've got. In this case, it knows it's numeric and it's linear, so it's giving us a regression model. It thinks that's the best choice for our data. It saves you having to know about all the different machine learning algorithms and models out there. So we'll accept that. And we're now going to decide which columns, which features we're going to use in our data set to actually feed into that machine learning model. And it says we're going to use all of them. It's automatically deselected acceleration because it doesn't think it has a very strong correlation with the output. So it does the key influences style analysis on this. And says acceleration, not that important. Now this uses a different algorithm to the one we saw in Power BI Desktop, which is why in this case it thinks acceleration is not very important. In Power BI Desktop it said it was, just different mathematical algorithms, so take it with a little pinch of salt. I'm going to include it here just for completeness. We're going to call this MPG, let's call it SQL bits MPG predictor. And we can decide how much training time we want to give this. Now this is auto ML, so what's going to happen is Power BI is going to not just train a single prediction model on your data. It's going to train lots of models, all of different algorithms, different settings, configurations, etc. And it's going to decide which one works best for you and give you that answer. The more training time you give it, the more different models it can use. So we're just going to leave it at 5 minutes and click Save and Train. So what does this do? We now have our data flow. If we go into this data flow, we now have our 3 entities. We've got the original MPG entity, which is the data, and this is historical data. This is data we know about. We know existing vehicles. We already know what their MPG is, and so we're going to use this to train our data, our prediction model. So straight away, it splits our data automatically into 2 different entities. First of all, a portion of it goes into our training data set, and then the remainder goes into our testing. So what's going to happen is that Power BI Data Flows is going to use this training data to train lots and lots and lots of models. And of those models, it'll use this testing data that it holds back to ask for a prediction of those and compare the results that it gets back with what it already knows the MPG is. And that's a way it can give it a test to see how good a model that is at predicting. And that's what it does for every single type of model. It goes through them all, works out the best one that's relevant in your data, and then you end up with a machine learning model. And here we go, here's our predictor model. And now with a little bit of video editing magic, we've fast forwarded 5 minutes and our machine learning model has been fully trained. We can see here the training status, and we can actually look at the information about this model. And using the View Model Accuracy button at the bottom, it's going to give us some information about the details of the model that it's created for us. And this will help us. It'll give us an idea about the quality of the predictions that it's able to create. So we can see here that it's given itself a score of 86%. 86% of the variation of the unpredictability of our MPG has now been predicted based on the other features that we've been able to provide. There's still a 14% variance that it can't explain, but that's a pretty good model. Here on the chart we see the actual predicted MPG versus the actual MPG, and we can see that it's actually a very, very good correlation. It tails off a little bit with higher MPGs where it gets a little bit skewed, but all in all it's a pretty good model. We can also look at the training details of this. And this is where we see, yeah, it actually went through 25 different models to try and find the best one for us. And we can see that the prediction quality changes quite dramatically over time. And if we look at the actual model itself, we can see it's actually using an ensemble model here. So it's actually generated 5 different models, and it thinks they're all very good in slightly different ways. And so it combines them all together into one result. So it's quite a complex system behind the scenes, but very, very easy to use. So now that we have our machine learning model, what are we going to do with it? Well, we need to use it to predict the MPG of new data for new vehicles that we don't know about yet. And how do we go about doing that? Well, if we go back into our data flow, we can then create a new entity, and this new entity is going to be our new live data. We'll again create a blank query and paste that in. And we're going to call this our new vehicle data. There we go. That's now going to validate that query. And then once we have that, that new entity in, we can then pass the data in that new entity through our machine learning model. Now note that we do already have the MPG column here. Ignore that. That's already there. We're going to ignore it for the prediction. We can just use it for a comparison afterwards. Okay, so now we're going to go to our machine learning model. We're going to take our predictor, we're going to apply it to our new vehicle data, and then give it an output column. And we're going to save and apply that. And that then creates 2 new output entities. The one with the actual enriched data, so that's an enhanced, enriched version of the data coming in. And also a data flow entity of explanations that helps give some insight into what's happening on that prediction. So now when we refresh this, the new vehicle data will load in from our source, it'll pass it through our model and output our enriched predictor. So now we have that, how do we consume these data flows? Well, if we go back to Power BI desktop, then when we choose Get Data, we can just choose Power BI Data Flows. This is now going to look into our Power BI account and give us all of the different data flows that we have access to see. There we go, let's choose this one. And we can see here there's an enriched MPG model that I created before because I haven't processed the one we've just done. And we can see all the columns there, including the regression result. Let's transform that data. As usual with most regression, with most ML models, the data gets returned as text, so we change that to a decimal, close and apply. And we can then use it like any other Power BI dataset. The beauty of this, though, is because it's a data flow, it's very easily shareable across different people, different data sets. So you can have one ML model resulting in one data flow, and then loads of different people in different Power BI data sets can consume that same output. So you're doing the predictions once and reusing it many times. There are some explanations in this column here. You get a more detailed explosion of that table in the explanations data flow entity. So what's actually happening here? Well, we load our data into our historical data into a data flow, and it's then split into 2 different groups. Around 80% goes into our training data flow, and the remaining 20% goes into our testing data flow. Then once we have that, we use those to train our model, and the AutoML algorithm comes up with the best model that can that gets the best results in the testing. Once we have that machine learning model, we can then bring in new data, new information, live data into another data flow, and that data flow can then use that prediction model to add the extra column we need to predict what that MPG value is going to be, and it outputs an enriched entity within our data flow, which we can then consume within Power BI. As well as that enriched data flow entity, it also creates an explanations entity as well, which gives us some more information about the detail as to how it came across that particular prediction. So this is AutoML. We don't really get any control over this. It's done for us by the AutoML algorithm. what if we actually want to create a machine learning model ourselves and have some influence into what it's doing and the actual decision of the algorithms being used? Well, for that we can use the Azure ML Studio. So we're just going to jump back into our Azure portal. And I've created a Machine Learning Studio Classic workspace here. And we create this in the Azure portal. And once we have this, we can then launch the Machine Learning Studio here. And once we have this, I'm going to have a look at my experiments. No, I would not like a tour, thank you very much. And I'm going to create a new experiment using the new button down the bottom. And there's a whole load of experiments here that you can preload, pre-created for you to get a feel for how it all works. We're going to start from scratch and create a blank experiment. Feeling brave here. Now on the left-hand side, you see a whole load of tasks or entities that you can drag on, including save data sets. We can upload our data into this. So if we've got our own data, we can just upload here and then consume it. But there's also a whole lot of sample data which you can use just to get started really easily. There's actually one here which is where I got the MPG data from, and so we can just grab that, drag it on, and this is then going to be our the start of our data set. We can right-click Visualize here, and we can have a look at the source of the data. Now we don't want this model column, so let's just get rid of that. So we're going to use a select columns and data sets, join those two together, and on the right hand side we launch the column selector, and we can choose all of the values that we want to bring in, excluding the model. Okay. Now we've got our the source data that we want to build something from. We need to split our data in two. So we're going to use the split task here, and we need to say what do we want our percentage to be. Let's go 0.8. So 80% of our data to go out of the first route, and then the remaining 20% to go out of the second. And now we can train our model. So let's choose train model, and we're going to pipe in our 80% of training data here. Whilst we're here, I'm just going to bring on score there as well, just to save time later on. Now we can't train our model without first of all selecting an algorithm that we want to use. Now I know that this is better off with a regression model, so I'm just going to search for regression, and there's a whole lot of different regression models that we can call upon. I'm going to go for let's go for boosted decision tree. That'll do. So we're going to plug that in. And in our model, what column are we going to predict? We're going to predict the MPG column. Okay. And then we can pipe the output of that into our score, and then take our 20% of test data and pipe that into our score there as well. So I'm just going to run that through. And that's now going to take our data, split it in two, use 80% to train our model using a boosted decision tree regression algorithm, and then it's going to score it. Now we can look at all sorts of information about we can evaluate the model and look at the stats of it. We haven't got time for that today. So what I'm going to do instead is I'm just going to productionize this. Let's say we've got an algorithm, we like the output, and we just want to get it working. Well, down the bottom we've got the Setup Web Service button. I'm going to set up a predictive web service, and it's just going to simplify things down a bit. Now, because in our source input, our training input, we had to remove the model name. We're not going to do that in reality. So in the real world, we're not going to have a model name. So we'll just connect that straight into our score. We're going to run that just to make sure everything tests okay. And assuming we get some green ticks, there we go. We can then deploy a web service. Again, button down the bottom. Let's give that a deploy. So what this is doing is this is compiling our experiment, it's compiling our machine learning prediction and then hosting it as a web service in Azure for us. And we can then, from any code we like, from C#, from Python, from Excel, we can hook in to that model, send up our data like our the weight of the car, the number of cylinders, the year, etc. Send all that up to that that API, the web service, and then it'll give us our prediction back. Now, we could write all the code. We don't need to because ML Studio helpfully gives us a test harness for this. So we can click the test button and it loads up a full test harness with all the information we need. So we can then give this a test by putting in some numbers and see what comes out. So we're going to, we can ignore the MPG column because obviously that's going to be the prediction. Cylinders, let's go for 8, displacement 2000, horsepower 200, weight, sorry that shouldn't be 2000, should be 200. Acceleration 0 to 16, I don't know, 10, year 1970, country code 1. And we then get a prediction of 20.3 MPG. And obviously we can then change these numbers. Let's make it 1980 and see if it gets better or worse. As we would expect, we then get a higher MPG of 24 because it's a newer model. So even though it didn't take very long to train the model, it took, what, 20 seconds or so, but it still has to go through that. That's with quite a small data set. To actually query the model is very, very quick. You can do it very, very quickly indeed. So I think that tests pretty well. And this also gives us all of the source code we need to be able to actually write our own code to interface with this. So there we go, here's all the C# code, Python code and R code. You can copy this into your application and it talks you through building up the JSON structure and then firing off to the web service. But we don't want to write code, we want to use Power BI for this. So let's go back into Power BI desktop. Let's go to this one and let's stick with our MPG dataset. So how are we going to interface with our newly deployed prediction model? Well, this is where the Azure machine learning option comes in with the AI insights. So within our MPG model, I'm going to click Azure Machine Learning. That's now going to look at our Azure Machine Learning models. And here we have one which is, let's find, there we go, that one there will do. And we can then say, right, let's hook in all of our columns, okay. And it's then going to add an additional column onto the end for us. Now this adds an entire record, so we just need to drill through into this and get rid of all the other columns. All we want is the actual scored label mean. We can get a standard deviation as well to give us some kind of understanding of the error there, but let's just go with that scored label mean. So we can see here this is now the predicted value. Change that to a decimal again. That's the predicted MPG of this vehicle. And you can see how quick that was. So every time we refresh this data set, we bring in new data from our source, it'll pass it through that algorithm and give us the response back again. So that was very easy. And we can also call that same ML system from a data flow as well, if you want to. So using that ML Studio, there's a reasonable amount of flexibility in there, and it does give you the option to be able to edit, to change the parameters of what you're doing, but it's still not the same as actually writing your own code. And Power BI does give you the option to write your own Python or R code if you want to as well. So to do this, I'm just going to load up an existing Power BI document that I've got. And importantly, I've already got Python installed on this PC. If I was using R, I would have to have that installed as well. And so what we can do with this now is we're going to do the same sentiment analysis in our tweets. So I'm going to go to, and so we've got this column here, the sentiment that this code creates. If we go back into Power Query, we can see how this works. When we get to this point, if we, where are we here, on the Transform tab, we have Run R script and Run Python script. And clicking that injects a step into our Power Query where we can just copy and paste or write our Python code. So this is the Python script that we have here. We can click on the cog next to it to see the details of it. And this is just a very, very simple 4-line Python bit of code. Let's zoom into that. And we have, critically, we're importing pandas. Now, the set of data, or the data set that comes from the previous Power Query step, is presented to Python as a pandas data frame. So once we import the pandas library, we can then interface with that data frame and access the columns that come from Power Query. Here I'm importing a sentiment intensity analyzer, which is the from the NLTK sentiment Vader library. And once we have those two imported, we can then add a new column called sentiment to our data set. Data set's the name, how we refer to the incoming data set from the previous Power Query line. And so we're going to add a new column called sentiments, and we're basing it on the tweet column and then applying our sentiment functionality to it. By all means, copy and paste that code in your own code. Note this uses your local Python installation and library. So you have to configure Power BI Desktop as to which Python library, Python installation you want to use in order for this to work. And the same with R. So once we've done that, we then get the results. Now it actually returns the whole thing as one table. So we have to then drill back through it, or drill into it rather, in order to get access to the underlying data. And then we end up with our sentiment column. So is that better or worse than using the cognitive services or calling an Azure ML script, etc.? It entirely depends. One of the, obviously it doesn't need to have Power BI Premium, which is a benefit. However, when you deploy this up to powerbi.com, it's not able to run the Python code within powerbi.com service. You have to have the personal Power BI gateway installed, and it has to be the personal gateway, not the enterprise gateway. And that has to be a gateway down to a machine that has the Python installation set up on it. And so what Power BI does is it takes the data sets, Power Query pulls the data in, passes it down to your personal gateway, it runs the Python code, and then sends you the results back. So you need to consider the potential performance implications of that with large data sets. But for most data sets, there's no problem at all with doing that. Is that better or worse? Well, it gives you more flexibility in the Python code, but it takes more coding. Obviously with cognitive services and the Azure ML Studio, it's just a much easier interface. It's all drag and drop and point and click without actually any coding to do. Just to go over some details of Python if you will want to have a play with that. You can install Python from python.org. You need to install the personal gateway on the machine with Python installed and then interface everything with the pandas data frame. To install the libraries that I just used, we're using pandas, NLTK and matplotlib. And then we're downloading the Vader lexicon, and then the 4 lines at the end are the code that I used to do the sentiment analysis. As well as using Python and R for data transformation within Power Query, you can also use it for advanced visualizations, using libraries such as matplotlib, ggplot, plotly in Python or R to take the data, the output in your data sets, and then add some quite advanced visualizations over and above what can be achieved through the built-in visualizations in Power BI. Right, so where does that leave us? Let's go back to our original agenda. We've looked through 6 different ways of of combining machine learning functionality into Power BI, and they all provide a slightly different experience on the spectrum of complexity or coding required against the power and the control that you have available to you. Obviously, the built-in Power BI visuals, incredibly easy. They're getting better all the time, but they don't really give you much flexibility. Then some custom visuals do, and then we go to the cognitive services, which give you quite a lot of ability to transform your data if they're aligned with the cognitive services that are available. If they're not, then you can go to data flow for analyzing your data with the automated ML, or if you actually want to do more complex work, we've got the Azure ML Studio option, hand-rolling your own machine learning model and then interfacing it from Power BI. And then at the very top end of the spectrum, you've got Python. I say Python or R, it's entirely your choice. They're both supported, and that's getting proper hands-on with the code, embedding Python into your actual Power BI data set. So with that, I'll wrap up and say thank you very much for staying here for this session. We do have some time for questions, so I'll be taking any questions now. Thank you very much.